écouter bi ñu xool fii comment on peut avoir un bon son ma régler fii ci micro bi.
Hello. 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 Ano sa kibit? Ano sa capsule? Ano?
Hello. Allô.
Hello. Hello everyone. Hello. Hello. C'est bon, bu nit ñi waxee. Sensibilité micro bi la du coup dafay ramasser un peu ambiance de fond bi mais bu conférence yi commencé normalement ça va aller. moo gën a sensible. On joue avec ça.
allo gis nga xaaral ma yokk fi ma xool.
Hello everyone. Hello everyone. Hello everyone. Non, je pense que j'entends pas. Hello. 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 Je pense que tout le monde entend. Just. Je pense que tout le monde entend.
Et celui qui va être là, on prend un trépied.
Non, celui qui présente, il est libre.
Ok, il n'a pas besoin.
De se mettre sur le micro. Il peut prendre avec la main gauche. Comme ça, il a son pour cliquer.
Ah.
Ou bien,
Comme tu avais vu la dame, elle était seulement là. Oui, vous savez, machin, la dame d'hier là.
oh, là c'est une dame, les hommes là, il faut les expliquer. Tu as le micro, tu as le qui est là pour communiquer. Quand tu regardes, tu appuies, tu l'as avec sa main là. Ça ne passe pas.
Juste pointer.
Non, moi j'ai dit que tu balances.
Tu veux que je balance?
Ouais, c'est simple. Il faut que la personne soit prisonnière.
C'est normal, hier on a fait comme ça.
Jusqu'à présent, c'est stable.
Client, tout simplement.
Donc c'est ça, vous avez vu. Mais donc on va continuer à vivre ici avec Orange. Ce matin, j'ai réglé une opération d'Orange, je vais prendre connexion. Jusqu'à présent, je ne suis pas encore servi. C'est comme ça. Hein? Même ta fête, même ta caisse quarantaine, même pas un conseil. Prendre mon appel, régler les soucis. Aujourd'hui, mon travail, je n'ai pas de problème pour le moment.
Hier, non. Et d'autres,
Je le laisse, il faisait court. Alors je viens.
Madame.
Yes, bro. Actually, for the presentation, I'll move over to that side. Yes. Very good morning, ladies and gentlemen. We'd like to welcome you to this morning's plenary session. A presentation should have been made by Professor Mbaye yesterday, but he traded places with Aminata. So we are going to have that presentation this morning. So it's my pleasure to invite Professor Ali Mbaye, who will be speaking to us on climate change, livelihoods, and conflict in the Sahel, to move over. The discussant is Professor Abang. He's hiding somewhere there, so you can join us here. So let's welcome him.
Very much, Mr. Chair. My presentation today is on climate change, livelihoods, and conflict in the Sahel. And here's the outline I'm going to follow throughout my presentation. First, I'll talk about the background, to give you some background on the Sahel. Second, I'll discuss the issue of climate change being a global trend with local perspectives, in particular with respect to the Sahel. And number three, I talk about climate change and livelihoods in the Sahel. And number four, I'll talk about climate change, livelihoods, and conflict in the Sahel, discussing hypotheses and evidences. And at last, I will discuss about policy options. Now, about the Sahel. What we need to know is that Sahelian countries share most of the features of all the sub-Saharan African countries, but they face some peculiar economic challenges. One important economic challenge is demographic bulge. Okay, population growth is high in the Sahel than anywhere else in the world. Actually, the record growth rate of population is Niger, with a growth rate averaging 4% per year. So it is unheard of elsewhere else in the world. As a consequence, youth makes up more than 65% of total labor force and are mostly either unemployed or underemployed. Poverty incidence in the Sahel is higher than everywhere else in Africa, with up to 80% of the population living on under $2 per day. Most Sahelian countries, if you, apart from Senegal, I mean, are landlocked. Mauritania is landlocked. Chad is landlocked. Mali is landlocked. All of them except Senegal. You have critical governance weaknesses, political turmoil and radical Islamist threats that have brought about serious security challenges in and across borders. And climate change is further amplifying these trends. I just would like to share with you this map of the Sahel, okay, for you to have a better picture of the countries which are involved. Usually when we talk about the Sahel, we refer to G5 Sahel. G5 Sahels only encompasses Mali, Niger, Chad, Burkina Faso, and Mauritania. They usually skip Senegal for whatever reason, and they don't consider Nigeria and Sudan. For Nigeria and Sudan, only part of them, part of their territory, are part of the Sahel. But this is the broader representation of the Sahel. So talking about the challenges, I just would like to take two examples, two illustrations. One is food insecurity, because it's what we are discussing today. As you can see, these figures show that Sahelian countries are facing food security at a greater level than other African countries. Because if you look at the Economist Intelligence Unit's Global Food Security Index, out of 113 countries, Mali is ranked 86, Senegal 87, Burkina 97, Niger 104, and Chad 108. Okay? So meaning that they are performing much less than other African countries, other developing countries, and other African countries in particular. And rising food prices are exacerbating food insecurity. And you can see that most Sahelian countries are concerned. Okay, you can see that almost all of them face dramatic increases in food prices, and these further amplify food insecurity. So food insecurity is one example I want you to take to show how poorly Sahelian countries are performing inside Africa in general. Another example I'm going to take is terror, insecurity and fragility. This is also predominant in the Sahel. And right now, Sahelian countries are drawing a lot of attention worldwide because of this phenomenon, the issue of violent conflict and terror. You have here a multi-layer of flows throughout the Sahel. And the arrows, the dots, the circles, and colors refer to different movement of items, of various items. You have legal goods, you have counterfeit goods, you have drugs, you have human trafficking, you have everything. You have financial flows, everything going through the Sahel with important ramifications outside the region. That's why Sahel is drawing that much attention worldwide. Now, our main argument is that climate change is further amplifying that. Our point is that it's not climate change that is the main driver, but it is amplifying existing challenges to bring about more violent conflict in the sub-region. About climate change, we have had very nice presentation yesterday from Alimentaire and Professor Joachim von Braun and from many others. So these are some just stylized facts, and I am not going to insist on. But one important point I would like to make is that climate change reveals a serious problem of equity worldwide. Because as everybody knows, African countries contribute the least to global emissions, and yet they bear the bulk of climate change effect. So here we have the contributions from different regions to global emissions. And you can see that the share of Africa is very small, okay, confirming what we were saying. And yet, Africa is hit hardest. Here we have the representation of loss in GDP by region. And you can see that despite contributing the least, Africa is hit, is part of the region of the world that are hit hardest. And the same story when you talk about land availability, arable land availability. You can see that land is shrinking, arable land is shrinking worldwide. But what is important in Africa is that the endowment was already low, and then it's further decreasing. So, and all these will have implications for food security. These are some charts you're familiar with, because some variations of these charts have been presented, and these are from our students in Burkina Faso. These refer to a standard precipitation index, and it shows that climate change is contributing to rising temperature. This is the case of Burkina, but results from other countries show the same patterns. And regarding precipitation, we have the same. And these effects on temperature and precipitations affect cereal production. And this chart from Remo Jatta in the Gambia illustrate this further. You can see a very clear correlation between rainfall and cereal production in the Gambia. But climate change also affects fisheries. Okay, we already had some challenges on our coastlines, but climate change is further amplifying that through several channels. Okay, floodings, loss of mangroves, okay, coastal erosions, intrusion of saline waters into inland water, making agriculture even more challenging, change of species, migration patterns, loss of coastal infrastructure, and the like. And I could have added health issues, because now we have very strong evidences that intrusion of saline water into inland water is provoking serious problems with infant mortality, because pregnant women who drink this water are exposed, much more exposed to high blood pressure, and their baby exposed to higher mortality. Okay, and now what are the options to adaptation? These are some figures from our students in Niger, and you can see that migration is ranked #1 on how population are responding to climate change, especially in rural areas. And selling off assets like reproductive animals and durables are also following options, and neither of these options is sustainable. And in Senegal, we can find an illustration of migration being an important coping strategy to climate change. You can see arrows going from and to anywhere, because almost all regions are facing climate challenges to different extents. For example, if you take coastal regions, they are facing sea level rise, and regions in the hinterlands, they are facing alternative damages related to climate change. And based on people's exposure to one or other challenges and hazards, will bring them to move in a direction or in another. Now, how is climate change affecting conflict? Climate change is affecting conflict in a variety of ways. First, rise in temperature and precipitation. This rise is putting a lot of stress on available resources, and people tend to fight over existing resources. This is well known and documented. Natural disaster. Okay, when you have natural disaster, of course, people tend to fight over available resources. Rise in sea level, we have already discussed that, and migration. When you have people move to another area, you usually find very serious competition with host people in terms of labor. And research shows that labor which are less educated are more likely to bring about this type of competition and fighting over existing jobs. And we have some compounding factors like weak governments and social fragmentation, which also come into play with climate change. Now, we have several typology of conflict. We have armed conflicts, combatant conflict, coups, rebellion, community, ethnic violence, wars. You have terrorism, you have unrest, you have riots, you have protests. You have all these playing out at the same time in the Sahel. And these are triggered by a different set of factors. Okay, we have climate-induced factors like, as we said earlier, fighting over increasingly scarce resources. You have corruption, you have favoritism. We'll come deeper onto those aspects. And you have amplifying factors like politically marginalized regions usually being hit harder, and post-disaster governmental responses being weak and or manipulated. And these we have plotted food price index against the number of annual riots, okay, in the Sahel. And you can see that we have a very clear increasing trend. And evidence in the literature shows that both variables are clearly related, meaning that when you have increase in temperature and you have variability in rainfall, likelihood of having a conflict is even higher. And Burke and al. Project a 54% increase in armed conflict incidents in Africa by 2030, or an additional 333,000 deaths. Okay, and they also found that 1 degree Celsius increase in temperature leads to 4.57 incidents of civil war in the same year, and a 0.9% increase in the next year. And this chart from the same author show the same. What we have here is projected percentage change in precipitation, and this is projected change in temperature, and these are the corresponding change on likelihood of conflict, okay, being measured in different ways. Okay, it means it tells the same story. Okay, we have some debates in the literature. Some authors are arguing that precipitation is much more relevant in explaining conflict than rainfall. Okay, and people are also disputing about how to construct variables. But this is not our main point. What we can see is that this evidence, because this is West Africa, this is the Sahel, we can see that increase in precipitation and temperature, okay, are expected to bring about significant impact on conflict. Region-wide, and in particular in the Sahel and in West Africa. This is also another set of evidences I wanted to show with you from the team of Miguel. It's about witch hunt murders in Tanzania. I very like this table because I'm quite sure that we will have exactly the same, similar figures in West Africa. Okay, because witch hunt murders exist everywhere in Africa. In particular in Burkina Faso, we have several cases of witch hunt murders which have been revealed. But these data are from Tanzania, but I brought them up here because, again, they tell the same story. Okay, what we can see is that most people who are affected are female. Most people who are affected are mostly aged people, people who had relatives, okay, people who lived in household with others, people who belong to a given ethnic groups. All this is also relevant to West Africa. Okay? Now, if you look at socio-economic characteristics of the victims, you can say that people who are victims usually are the poorer. Those who are below average in terms of ownership of assets. Okay? And those also who are below average in terms of ownership of livestock, okay, and land, same story. But what is really interesting is here, okay, the timing of each murders, okay. Pre-harvest season is the period of time where most of these murders occur, okay, lending another support, an additional support to this increasingly strong body of evidence on this issue. Although we have a lot of issues being disputed on this, but I'll come back onto this issue. Okay, but what is real is that 3 minutes. We have an interaction between climate change and other factors. In particular governance-related factors in explaining conflict. You have a lot of tradition of political favoritism, which is pervasive in Africa. Ethnic connections and voting determines who benefits and who loses from government policies. voting in Africa is very much explained by ethnicity, everywhere in Africa. For example, we had our election, our national election here in Senegal last year, and one of the incumbent, the incumbent president, who is from the north, he received 94% of the voting from the north. And his challenger, who was from the south, received the same magnitude of votes from the south. So this is important. And people who vote, or localities who vote from the ruling party, just are paid back in terms of investment, in terms of transfers, in terms of budget expenditure. Okay? And you have some marginalized groups which are residing in areas where land is less fertile. So this is very important. And the way adaptation to climate change is managed by the government, and disaster also response is managed also is a challenge. And all these inequalities are bringing about increasingly conflict. This is also evidence from Kenya about favoritism. Okay, what we can see is that service provision in terms of roads in Kenya, okay, comparing co-ethnic districts and non-co-ethnic districts, and you can see that co-ethnic districts are receiving much more funding than non-co-ethnic districts. Okay, now let me come back much more closely to the Sahel. Farmers and pastoralists have long coexisted in the Sahel, and local institutions used to mediate rising conflict with sizable success, even though we used to have also some conflict, but they have been much more successful in mediating this conflict. We have undertaken some surveys in Mopti in Mali and in Difa in Niger, which confirm this, but I will not show the result. Okay? This is one example, is the Niger River in Mali and in Niger. Okay? You have many population drawing their livelihoods from the rivers, the farmers, the herders, and the fishermen. Okay? But increasingly, because of this set of factors, we have conflict arising. And I would like to close with these case studies in Mali. And this relates to the case of rice and burgu. Burgu is a fodder for cattle that herders used to grow in the river. They used to use the rivers, but not at the same level. Okay? The cultivation of burgu happens deeper inside the river, while the cultivation of rice is more shallow. Okay? But now what is happening with climate change is that the riverbed is withdrawing, and you have farmers increasingly intruding herders' field. So trending to cultivate rice on fields traditionally used for herders to grow burgu. And this is an important cause of conflict. And you have witnesses all these slaughters which happened in Mali between the Bambara and the Fulani. We had one instance where 160 Fulani were slaughtered by the Bambara. And as a retaliation to a former slaughter of 100 Bambara being slaughtered by the Fulani. Okay? And what you can see is that the Fulani and the Tuaregs tend to be Muslims. The Bambara and the Songhai are animists, which is traditional African religions. And the Fulani and the Tuareg are increasingly joining the jihadist insurrection in northern Mali due to the dual pressure of alleged government discrimination and climate change. Amadou Koufa is a leader of the mouvement pour l'unicité et le djihad en Afrique de l'Ouest, Mujao. So whenever you have a jihadist attack, usually targeting the Bambara and the Songhai, you have similar retaliation happening. Okay? So I just wanted to talk about the policy option. Mr. Chair, do I have 2 minutes to do it?
Maximum.
Thank you very much. Okay, now, mitigation adaptation. What's really a challenge is that most funds available for climate policy are mainly earmarked for mitigation. Adaptation receive very few attention in terms of funding. Okay, and mitigation is not a big issue for Africa, given what I showed you earlier. I mean, Africa's tiny contribution to emission. So adapting to the rising effect of climate change on human livelihood is the biggest issue for Africa. Okay, and so far, adaptive capacity reveals very weak. In terms of mitigation, economists usually favor carbon pricing and trading mechanism. Professor Von Braun discussed this yesterday, and the general principle is pricing is the most effective way to curb emission, but the reality is it is not, price is not helping curbing emission. But for Africa, we are in a very bad need of assistance to adjust to all these climate disasters. And we have several policy options. We will have options which will be available on the field, okay? And this is some example of risk management applicable to climate. We have just released a volume on this topic, okay? Unfortunately, it's in French, okay? Various tools designed to manage risk, in particular climate risk, but this is likely not to be enough. We need increased flows for adaptation, and we need these flows to be managed differently than standard overseas development assistance. Thank you very much, Mr. Chair.
Well, thank you very much, Professor Alimbaye. I would like to give you 5 minutes to discuss it. Very clear presentation.
I don't know. I think Professor Alimbaye has actually done an exhaustive job. I think the title of the paper was well crafted. As you can see, climate change, livelihoods, conflicts in Sahel. He presents the papers in a number of sections from a background, climate change in West Africa, trends and local. Divide the paper actually into 5 sections. Presents the challenge or challenges. Some of the challenges are high population growth rate in the Sahel, with an average population growth rate of about 4%. And of this population growth, the youths make up about 65% of that. And these youths are basically unemployed or underemployed. About 80% of them earn less than $2 per day. It's a very serious challenge. Almost all of these Sahel countries are landlocked, meaning they can trade only within the confines of land economy. They have weak leadership trends, and the Sahel region identifies the areas that it considers as Sahel region. I was shocked, and in fact, for the first time, I didn't think that Nigeria was one, but it now mentions Nigeria, so I've been educated in that. We had other areas. In fact, he says that Mali, Niger, Sudan, part of the Sahel, which I already knew. The challenges are in 2 areas: food and security. Food is aggravated by climate change, according to the study. These countries basically are food insecure, and gives examples from the Food Security Index. Dramatically, food prices are rising in the area, and as well we have terror and insecurity and fragile systems. Sahel countries are getting attention worldwide because of the conflicts that have been exacerbated by terrorism. Argues that climate change amplifies the conflicts, not the reverse. It gives examples of papers of such conflicts. Climate brings problems of inequity. Africa contributes less to problems of climate change, but yet is impacted most from such issues. Africa is hit hardest. Example, loss of GDP. Arable land is shrinking, but the endowments are low and further increasing. These have implications on security. So he goes further to talk about climate change that results in high population. Climate change results in high temperatures and precipitation. The effect of climate change, in fact, is that temperatures are rising in the Sahel region and precipitation is also rising. The combination of these two gives a correlation that between cereals and fisheries, as well as coastal erosion and migration patterns, as well as health. What that means is that because of rising temperatures, and precipitation, there's a strong correlation between production of cereals, production of fisheries, and coastal erosion. This, as a consequence, results in migration patterns and health issues. These are issues that he discusses very deeply. What are the options? There are policy options. The first policy option he talks about is migration. People to live from the areas that are climate-prone areas to less. And then in that one, he talks about selling off assets. Those are the issues he discussed. Now, how climate change is affecting these conflicts? A rise in temperature and precipitation, natural disasters, rise in cereals and migration, compounding factors, wealth and governance. Those are the impact of climate change on the Sahel region. I think he developed the topography of these conflicts, and he talks about them as unrest. It creates unrest, riots, and as a result of temperature increase. These increases are triggered by different factors. So on this basis, he presents evidence that result in these, how temperature and precipitation affects conflicts. He also relates the socioeconomic characteristics and seasonal variation increases on climate change. On this basis, he gives the example of how social economic characteristics could affect the place, and gives the example of Tanzania, where because of climate change and the pressures, people are affected through witch hunt, which gives a number of examples. Interaction of climate change and governance also is generating conflicts. Evidence of ethnic and favoritism in public issues, conflicts between agriculturists and pastoralists in the Sahel region. It gives examples. Conflicts in competition to access water. A case of Mauritania. Example, case of conflict between cattle and rice production. Gives examples of the Fulanis and the Bambara and Songhai. Presents two main areas in terms of climate policy. One, it talks about migration, people could migrate. The other one, it talks about adaptation. And finally, it talks about improving access to green funds. Those are the key things that I got from this presentation. Thank you.
Please, let's appreciate the presenter and the discussant. So we will move on. Conflict will naturally induce migration. So I'd like to invite Alex Doshabinin to migrate to the podium. To discuss this paper is Professor Alexo YG Egbendewe. You're welcome. Please, let's appreciate them.
Alex. So I'd like to ask, d'abord je m'excuse de parler en anglais, de présenter en anglais. I'd like to ask the chair for a little forbearance because I'm summarizing a 200-page report in a very short time, but I will do my best to get through everything. I want to acknowledge my co-authors, Kanta Kumari Rigo, who's at the World Bank, Brian Jones, who did the modeling work at CUNY in New York, and my colleague Susanna Adamo at our center at the Earth Institute at Columbia University. So this work builds on the Groundswell project, which was released in 2018, this report you see on the right-hand side. And the purpose behind that was to better plan and prepare for the likely movement of people within countries as a consequence of climate change. They also wanted to understand areas of greatest vulnerability and therefore likely areas of either out-migration or in-migration. And they wanted to support a constructive dialogue with countries, World Bank member countries, to drive informed policy and action. I want to very carefully say that the results are not seen as a crystal ball in some kind of predictive way, but they're a way of essentially engaging in dialogue on the subject. This work was funded by the WACA project, which is West African Coastal Adaptation. So what we did was we built on the original Groundswell model, and we enhanced it in some ways that I'll describe. I'm going to skip this in the interest of time and go right into the approach and methods. I realized I was surrounded by economists yesterday, and so I had to increase the number of slides dedicated to methodology and to some equations. So our interest is in this area on the left-hand side, which is internal climate migration, which could be either more voluntary, meaning economic migration, or people who leave largely out of their own ability to move, and ranges to more forced, which is essentially people who are unable to really choose but may be forced, essentially displaced. You see other types of mobility and immobility listed here. On the right-hand side, there's something called what we would call trapped populations, people who are so poor and who have so few resources that they are unable to move. This is an increasing dialogue in the climate change migration literature. We also did not discuss or really address cross-border migration, either refugee movements or voluntary movements. Our approach was based on essentially 4 scenarios. The original Groundswell only had 3 scenarios, but we added the optimistic scenario. On the y-axis, these range from low to high emission scenarios, and on the on the x-axis, those are y-axis, low to high emissions. X-axis is inclusive development, which is a more optimistic development scenario, to a more inequitable development scenario under the shared socioeconomic pathway 4. So in the top right, you see essentially what we call the reference scenario, which is a pessimistic world. You have both inequitable development, so that means very rapid population growth rates in developing countries, in the least developed countries, and also very high emissions. In the lower left-hand corner, you see a more optimistic scenario, and then you have others which include variations of high emissions and more equitable development, and low emissions and more inequitable development. All of these data were run at a 1 kilometer. So what we did is we projected forward population on a 1 kilometer basis. So we took a baseline population of 2010 and we projected it forward to 2050. So these are spatially explicit population projections. What we did is we basically looked at the difference between a scenario that included climate impacts and a scenario that did not include climate impacts. So if you take the pessimistic scenario, we compare that to SSP4 without climate impacts. So this is a no climate impact world. And we basically look at the differences for each grid cell. Where there are positive differences, that means we interpret that to mean that people are moving into an area due to the climate impacts. Where there are negative numbers, they're interpreted as people moving out of an area or out migration. So that's how we derive our estimates of migration. It's from two different population projection scenarios that are spatially explicit, one with climate impacts and one without. Everything was done at a national level and then aggregated to the regional level. Within each of those scenarios, we used four different model combinations. These included combinations of the SSPs, so 2 and 4, as I mentioned before, and different climate impacts on crop production, so wheat. In this region, it would be maize, primarily, and rice, but there's also wheat and soya in other regions, and water availability under 2 emission scenarios, high and low. And so we used also different GCMs to drive this. So we had 2 different GCMs. One was from Hadley Center, and the other was from IPSL, which is a French model. The matrix below shows that these combinations of models were not done completely across the board. In the interest of time, and really because we had very little time to produce these results, we used essentially 4 model runs combining different GCMs and different crop and water models. We also had sea level rise. We had a very high level sort of, I would say, what's the word? Not optimistic, but sort of generous sea level rise of 1 meter by 2050, which would include storm surge and saltwater intrusion and flooding and other things that happen in the coast, and 2 meters by 2050 under a high emission scenario. Again, very high, not expected to be that level by 2050, but we wanted to account for things like surge and saltwater intrusion. In this new work, we included ecosystem impacts. So in the old work, we had crop impacts, but where there's no cropping, there was no data, essentially, in the model. So what we did is we filled in where there's no cropping, we had ecosystem impacts, which is net primary productivity. In those areas, assumed to be rangelands or pasture lands or other things, maybe forests. Inclusion of conflict areas, we had shorter time steps. In the original work, we did 10-year time steps. In this new work, we did 5-year time steps. And we did it all at a 1-kilometer resolution, instead of the original work, which was at a 15-kilometer resolution. The basic approach is a gravity model. So gravity models are very good at replicating past changes in population distribution. Because basically what we've seen historically is that urban areas tend to attract people and rural areas tend to send people. In a very sort of grosso modo, that's the way things have happened historically. But at the center of this is a notion of population potential. So for each grid cell, you calculate for a 100-kilometer radius around it what the potential is for that grid cell in the next time step. Then it creates a population potential surface, and then that potential surface then drives the new population distribution in the next time step. In this case, 5 years from the beginning time step. And we did this again and again over the 50-year period. So we divided it into 5-year time steps, and we did it for the, well, it wasn't 50-year, it was 40 years from 2010 to 2050. Population agglomeration is a proxy for the socioeconomic characteristics that make places attractive. So think about services, think about education, think about healthcare, think about jobs. And that's why people are mainly moving from one place to another. But what we did is we added on top of that, we already know those things are driving migration, but we wanted to look at what an additional effect climate impacts might have on the attractiveness of locations. So that will affect the population potential by doing this. Essentially, we have this negative exponential function, which includes population and distance, which are the two factors that largely went into the old population gravity model. And I apologize for the top left box, but that's basically the local characteristics that include things like the climate impacts, conflict, sea level rise. Oh, I'm sorry, sea level rise is actually included as a spatial mask. So what happens with sea level rise is we simply take land out of circulation. So at the coastal zone, at the coastal margin, we simply take land out of circulation and people can no longer move into those. Potential is calculated, like I said, over a 100-kilometer window, and the parameters alpha and beta are estimates from historical data for both urban and rural distributions. So urban and rural populations are projected separately, and as I said, A is a weight on the potential indicative of the local impact of climate variables. The parameters alpha and beta are estimated from historic data, so we take the essentially 20 years, from 1990 to 2000 and 2000 to 2010, and we look at the change in population distribution. This curve is supposed to very generalized sort of representation of a population distribution from a dense urban area on the left-hand side to a less dense rural area on the right-hand side. But what we see is in each time step, the difference between the predicted population from the gravity model and the actual population distribution from the observed data can be seen where there's these actual differences. And what we're trying to do is use the climate parameters to essentially explain that error term. So we hypothesize that these errors can be explained in part by local environmental characteristics, which are used to estimate the A parameter. For each cell I, we calculate the value of A necessary to eliminate the error, or E, and this value is we call this the value of observed A. So what we have here is the actual parameters or coefficients used from the historic data for those two 10-year periods. It's an average of the two periods. And what we see is that water availability affects both urban and rural populations the most. It has the highest parameter or coefficient. What we see is that the rural populations are also affected by crop yield and net primary productivity, but to a lesser extent. And we also have some other factors that we added to our work, which included age distribution and sex ratio, which are known factors that affect migration. We use conflict as well, and I'll show you a map of some of the conflict zones later. And then we also included flood risk in this new modeling work. So what I want to make clear is that that we highlight a lot of the caveats of this work in the original groundswell report. So you can read that report. It's available online. You can download it. And these are not maps of the future, but plausible scenarios that should be understood as essentially ways for the decision makers to begin thinking about these issues. So what do we know about the sort of background for West Africa? We have about 400 million people as of 2019. It's expected to double by 2050 to 810 million people, so close to 1 billion people in the region. There's a very large youth population. There's heavy concentration along the coast and also in some of the inland sort of dryland areas, northern Nigeria, southern Niger, and Burkina Faso. Very high rates of urbanization as well. It's 4% urbanization compared to about 2% urbanization in the world at large. So we have very, very rapid rural to urban migration. Is this working? Okay. So historically, it's a mobile region. As you know, ECOWAS, the policy framework for the region, is basically one of pretty much open borders. If you live in the region, you can live and work in other countries. There's been an acceleration of internal migration with very high urbanization, as I mentioned. You have higher and rising international migration, both within the region, but also external to Europe. And the persistent conflicts, as Ali Mbaye mentioned earlier, are occurring in different regions. So this was the conflict data layer that we included. It does not include, for instance, Burkina Faso, because the data we had available to us did not include there. We also know that dryland areas have been an area of the world where migration has been used as a risk management strategy over many, many centuries. So it's not a new phenomena. Basically, people use migration as a way of sort of hedging their bets. So they'll send 1 or 2 household members to an urban area and they'll receive remittances in return. Dry season migration has been a very common phenomena for many, many centuries. But we also know that, so migration is a reality, it's happening already, but there are a lot of other ways that communities and households are dealing with the threat of climate change already. They're using livelihood diversification, food aid, social networks, religious activities, water management, crop, livestock, soil, and water management. So there are a number of different strategies that they're using. In the coastal zone, one of the things that we have not seen yet is any change in the level of migration into the coastal zone. So climate change is certainly not a factor affecting current migration trends. It's also, so I already mentioned the long history of mobility. Cultural factors are very important, and some people have talked about the passage that for many, at least Senegalese and maybe other youth in the region, I lived in Mauritania actually for 2 or 3 years in the south of Mauritania near Bakel, Senegal, and I saw that that was really a rite of passage. You had a certain pride if you went out and you made your way in the world, you came back, you had a big boo-boo, you had, you know, in Sonike they said, wunohore means the large pants with a lot of fabric, and that was a sign that you had made it. So there's a lot of cultural drivers behind this as well, and we don't want to ignore those. But there's a growing body of research has found evidence that migration decisions are being influenced by climate change and variability. So there's a lot of work going on in this area. But we also know that there will be in the future both migration and trap populations, those who need assistance in local areas. These are sort of summaries of the future climate projections. And what I want to point out here is what we did is over the 40-year period, this is sort of a summary of the 40-year period, and it looks at the baseline of a longer time climate normal time period for hydrology, for instance, in this case, water availability. And we compare that to the future. So what this is essentially differences. So where you see negative 0.7, negative 0.9, that's about a 70% decline or 90% decline in water availability. Where you see 2 or greater, that means it's a doubling or more of water availability. But remember that that's against a very low baseline in some of these arid northern areas. So if you go from 10 millimeters to 20 millimeters, you've doubled your water availability, but that doesn't mean you can actually grow any crops there. What's important to realize is that the western portion of the Sahel is more likely to see a decline in water availability, so Senegal in particular, and the eastern portion of the Sahel is likely to see wetting, at least under the climate models that we had at our disposition. If you take the whole suite of CMIP 4 or 5 climate models, split roughly between those that projected wetting and those that projected drying in the eastern Sahel. Unfortunately, our models only saw a wetting, and that was just a limitation of our work. These are the crop model impacts. Brown areas, again, indicate declines. Blue areas indicate increases. It's much more spotty with these models, so it's a little bit harder to interpret exactly what's going to happen, except that you see some areas of decline up in the northern reaches of the agricultural limits. And this is the net primary productivity or the ecosystem models, and you see basically similar to the water models, a drying in sort of the western Sahel, but also increased precipitation and net primary productivity in the northern areas, in some areas. Sea level rise projections I already discussed, and basically we're seeing accelerated coastal erosion already and saltwater intrusion in different areas. So let's look at Senegal and see what some of the results suggest. The population of Senegal is about 16 million. It's projected under SSP2 to be 26 million, and it's under SSP4, which is, remember, the more inequitable and less desirable development scenario, it's projected to be 33 million. Almost a quarter of the population is in the coastal area, and that reflects already a pattern of rural to urban migration that's happened over a long period in Senegal. The projection, as I mentioned, project drying in much of the country, although there could be some wetting or increased water availability in the east. In the interest of time, and because water is the most important parameter in this modeling work, I'm only showing the water projections here, impact projections. Excuse me. So what we see overall is a potential total on the upper right-hand corner for the pessimistic scenario of 600 million, maybe up to 600,000, maybe up to 1 million migrants, which could be up to 2% of the population under SSP4. In the optimistic scenario, it may be as low in internal migration, it may be low as maybe 75,000. So there's a very wide range, obviously, depending on which scenario occurs. And what you see is the uncertainty bands are the reflection of the 4 model runs per scenario. And what you see is under the RCP 8.5 or high emission scenario, there's much more variation in the climate impacts. And so therefore the bands are much wider, going from 200,000 to 1 million in the pessimistic reference scenario. We can also map the hotspots of climate migration. The way we do this is basically we take the top 5% most negative grid cells, so the top 5% negative and the top 5% positive grid cells. So remember, positive grid cells are in migration or red areas, and negative cells are out migration or blue areas. And we pile those 4 scenarios on top of each other, and where they coincide, we have higher certainty. So if the 4 scenarios all agree that that will be an area of out migration, it's a darker blue. If they all agree that it'll be an area of in-migration, it's a darker red. So you see areas of Matam and parts of the Casamance might be, in the future in 2050, new in-migration areas. But what you see is areas around Dakar are likely climate out-migration areas. Let me be very, very, very clear here. This does not mean that Dakar is going to depopulate. What it means is that, so what you see here is that population growth will be pretty much consistent and greater in the Dakar area across all scenarios. This is the projections for each of the 4 scenarios here out into 2050, based on a comparison between 2010 and 2050. So there'll be growth in the western part of the country, but the important thing is to realize that the growth will be attenuated or will be less than would be expected under a no climate scenario. Does that make sense? Do people understand where I'm going? So this map just shows that growth will be less than might be otherwise expected in Dakar because of the influence of climate change, largely because of the drying in the area and also because of sea level rise. You see the same in the Sine Saloum Delta, and you see some in the Casamance as well, areas of outmigration because of these climate impacts. So lower than expected growth in those areas because of climate impacts. We did this for every country in the region, and this just shows some of the projected numbers in some of the countries. So as one might expect, the y-axis are not comparable because they're different for each country. Nigeria has the greatest numbers because of its large population size, so it goes up to around 20 million people, internal migrants by I apologize, the black bars are the what we call other internal migrants or development migrants, and I won't go into that right now, but the yellow bar shows that Nigeria may see as many as 8 to 10 million people migrating by 2050. We have Togo, Benin, Cote d'Ivoire, etc. What we did here, thank you. What we did here is you see the blue, this is country by country, what are the hot spots? So this is the top 5% highest in migration in red areas and top 5% lowest out migration in blue areas. And you see southern Niger, parts of western Mali along the border with Mauritania are all areas of out migration, and then some areas in northern Nigeria like Kano being areas of in-migration. This is country by country. What you can see, if you take the region as a whole and you look at the top 5% and the bottom 5% in and out migration hotspots for the region, the areas with the greatest population density and the largest populations are basically those that show up as being in and out migration hotspots. So Benin shows a lot of out migration. Southern Niger shows, a lot of in-migration in Benin, and there's a lot of out-migration in southern Niger. And this is sort of the progression over time. I have greater confidence in the country level projections than I do in this, and I can get into that more in discussion if you want. So what we see is climate migration increases over time. The pessimistic scenario is always the worst case, and it always has the highest levels of migration. We did not game the modeling in any way. The modeling is what it is. It shows that higher climate impacts actually results in higher climate migration. So basically, what are some of the pros and cons of this model? And I'm about to wrap up, so don't worry, Mr. Chair. Thank you. There are pros, which is that the gravity model is able to produce past shifts in population distribution, so it's based on empirical evidence. It's not just dreamed up out of thin air. Modeling is based on impacts to relevant sectors rather than climate variables. This is very important. We didn't just look at precipitation change and temperature change. We actually used the ICIMIP, which is the Intersectoral Impact Model and Comparison Project. We used the ICIMIP data on crop and water and NPP impacts to drive this modeling effort. The model is flexible in terms of scale and data input, so we can add different variables, we can subtract, but they have to be spatially relevant. For the most part, we want to have projections of those variables into the future. It can generate results over broad scales and raise the profile of an important issue. So like I said, we do not believe these numbers are exact or precise. Nobody's going to be in 2050 with a badge saying, I'm a climate migrant. Thank you, let me introduce myself. It is probably more likely that there's going to be a mix of factors. On the cons or the negative side of this modeling approach, it can be seen as overly deterministic or mechanistic. It does not capture household level decision making. If you want to do that, you need an agent-based model. Unfortunately, agent-based models require a lot of input parameters that you are not going to be able to get on a global scale. So that you're really not going to be able to do global modeling with an agent-based model. It does not address many of the political and economy factors such as access to land, resources, jobs, or shocks such as political or economic or other shocks. We do not know what the future will hold in many of these regions. We talked about conflict earlier, and there could be important conflict drivers in the future. And it purposely does not include improvements to crop varieties, irrigation, water-saving technologies, or coastal defenses. I just want to mention in closing that there are a couple new opportunities. We have an NSF convergence proposal on transdisciplinary research related to climate change, food security, and migration in West Africa. We're actively looking for regions or areas that we might actually do our work in. So if you have suggestions, and particularly areas that have rich data sources. I learned that IRD, the French Research Institute, for instance, has a laboratory on population and development in Senegal. So they've been collecting data for something like 50 or 60 years in that region. But I'd like to learn more about areas where you think we should do that field work, because we will be running an agent-based model for that work. And then I also want to encourage you to join coordinate a network called the Population Environment Research Network, or PERN. This is a network of demographers, geographers, earth scientists, climate scientists, a whole range of people. We're between the IUSSP, which is a demographic international union, and Future Earth. And we will be holding in 2020 online seminar. So this is available to anyone, anywhere in the world, on the issues around climate change, food security, and demography, population dynamics. So with that, I welcome the comments of my esteemed colleague from Togo.
Thank you to Alex. So
you have 7 minutes.
7, okay, thank you. So again, thank to Alex for this work that you have been doing, because when we talk about internal migration, we really don't have data on those people that migrate internally into a country, or even when we take the West African region, we don't really have very good record in terms of people who move from one country to the other country. And so the best way to understand those issues is basically to go through modeling. And so when you talk about modeling, really it requires a lot of work, and So we really appreciate what you are doing out there. So because for us as economists, to do those type of work, we need the data set, and we really don't have those data set. But as people move out and in from a country, then the need of infrastructure in terms of, like you said, infrastructure for health, hospitals, or for education, those things have to be predicted so that the government can put in place infrastructure to basically accommodate those people who come from disasters or climate change effects. And so these are basically the importance of this modeling work that you guys have been doing at Columbia. So then you use the RCPs and the SSPs as well, so that we can cross climate scenarios with socioeconomic prediction or scenarios as well, which basically will help us understand basically how those two things interact to predict internal migration. And so, like you said, you also have used the scenario without climate change and then the scenario with climate change to basically look into your grid cells, because you were talking about grid cells, to see how people are moving in or out based on the density that of population in the grid cells. And you also actually take into account crop production, which basically is one of the issue in West Africa, where we have done some work and we have seen that yield are declining. And so people who live in rural area may want to move elsewhere, because if they don't have any other way to live, then they have to move away from those places. And we have to think about where they are going and what are they going to be doing. Do they have enough of education to get a job in a city? And I see people moving a lot, even from my country to Dakar. I see many people from Togo when I go to the restaurants. And so, which means that people are moving away from places. It's true that they are not moving away only from climate change issues, disasters, but also from countries that politically seem to not have very good are not very good places to live, and so people are moving away looking for better places. And also you have included water availability, which also is important, because in the Sahel area, where you have more water stress and also conflict, because people are looking for water sources for livestock and agricultural production, those people basically are under pressure in terms of moving away from their places to better places. Sea level rise, and then you see that when you move across our coastal line, for example, when you go to Togo, then you see that currently we have the third road that have been constructed by the government, because the two former roads have been destroyed by the coastal erosion, and people who are there have to move away because they don't have any asset. The asset that they have before are those land that they are using to grow crop and to live on. Now, the sea level rise has destroyed all those infrastructure. People have to live away from those places because they don't have anything else left. All the land has been taken away by the sea level rise. In terms of modeling, the gravity model is also used by economists in terms of studying trade, and so I think this is a good model, because we don't have, like you said, the agent-based model also are good, but data sets are not there to compute all the parameters that you need to drive the model. And so those are the things that have been used to drive the model. And now, when you come to the studies, to the country level studies, Senegal and all those countries, so what I've seen there is basically most countries will have very high population growth in Africa. And that's something that people are worrying about. But we also think that probably by the end of the century, the population growth might decline because of the economic issue that people will have to face. And women that are now educated, they don't stay at home anymore, so they don't want to have many children. They want to reduce the number of children because they want to work as well. There are many women now that are educated, and so they don't want to stay home and raise children. They want to work as well because their parent has invested in them so they can work, not to stay at home and raise children. And those are the issues that we are thinking about, that might play against the rise of the population growth, probably by the middle of the century. I don't know whether you have taken those into account or not, but probably those are issues that we might also consider. In Senegal, like Professor Alimbaye has said, Senegal is also a part of Sahel countries, and so those countries will face a lot of water stress. And conflict might also arise as well as a result. But we also think that probably economic growth, people are putting in place policies to basically improve economic growth in our countries. And many countries are doing well. It's true that in terms of how this growth is distributed, probably we can see more of inequalities while we have also economic growth. But probably the economic growth may probably mitigate the climate effect on population. And I don't know whether you have considered that or not in your modeling, that probably we may have more economic growth, and probably the government may put in place more infrastructure to help, accommodate people who are moving in and out. Those are the issues that I think we might also consider, so that we are not very pessimistic in terms of the effect of climate change when we have strong economic growth. Even though some countries might not have very strong economic growth, but some may have. When you take also issues about institution, because when we talk about Africa today, we have a lot of institutional problems, corruption, and all of those issues, which might also exacerbate the effect of climate change on internal migration. And I think those also are issues that you might also, if it's possible, because we have data today on corruption, government effectiveness, and all of the data that we have on governance. Probably those data, if possible, that might be used to also see what they create in terms of whether they exacerbate or whether they reduce the impact of climate change on internal migrations. Thank you, sir.
Thank you so very much. We have 8 minutes, and we'll spend it very usefully to generally discuss the two papers. May I invite Alimbaye and Alex to join at this end. The duo and discussants have actually raised some pertinent issues. Population appears to be very key amongst the issues that they have raised. I have a personal worry about the population question in West Africa, Nigeria in particular. I worry about the numbers. I'm not sure the numbers are real, and we will continue to build on false figures, and so it will appear as if the population is blossoming, and that may not necessarily be so. We have some very heavy spots of population concentration, people moving from rural areas to urban areas. And when you go to most rural areas, they are deserted. You don't have human beings there. So we probably will have to properly interrogate the population question in sub-Saharan Africa. Over to you, distinguished audience. We have 8 minutes to go, so we'll invite questions, comments. Yes, let me start from that end. Introduce yourself, and okay, then Joachim.
Okay, thank you, President. Thank you for the two presenters, Prof. Ali and Dr. Ali. I'm Nike Zamo. I will be soon a doctor from Waskal UCAT. I have a question for Professor Ali, for Alex. My question for Professor Ali is, what is the suggesting solution to reduce pressure on resources in the Sahel and then to reduce conflicts due to climate change? And for Alex, when people are moving from one place to another because of lack of resources, of course, they will create pressure on the available resources in the new environment where they are going. So at this case, are they not going to have like a vicious circle where people will move because of lack of resources? When they will move, they will create pressure on resources where they are going. So which solution are you suggesting in this case?
Yeah, Joachim. Joachim, please.
Thank you. My question goes to you, Ali. Thank you for a very challenging set of issues which you have laid out. It's difficult for economists to deal with complex issues. Complexity theory needs to be embraced probably more by us. I have one suggestion and one question. The suggestion is we probably need to broaden our agenda from climate change economics towards development economics, period. That's what you have, what I take from your talk. What is the comprehensive response to the issues in the Sahel which you have laid out, and what role employment? What's the comprehensive approach to deal with the huge issues? I think if we can lay that out, the comprehensive approach, I think the case for investment can be easily made from the countries themselves and from abroad to deal with the complex issues.
Thank you very much. A pleasure to be here. My name is Ngozi Amu. I'm head of research and analysis at the UN Office for West Africa and the Sahel. Thank you very much to the presenters. Very interesting also to be in a university environment. I wanted to ask Professor Mbai Ali first about the mitigation. There's a lot of talk right now about Africa not contributing very much to global warming. And there's also a sense on the political side that that means we don't have to do very much. And I wanted to know, this issue about deforestation, it's not mentioning enough in this research. And we know that that also contributes to greenhouse gas emissions. So do you have any research on that? And also, linked to that, you know, there's a lot of discussion about the Lake Chad Basin, and I understand that the Nigerian government is trying to get water from the Congo River, and also that's very much the political kind of issues around it, rather than as a country dealing with other solutions. So just again on mitigation and how that could be easily politicized. And then I wanted to Professor Alex, I wanted to ask about the modeling. Again, given that Nigeria has half the population of this region, it's almost like it's a place of its own. And so when you do this modeling, and also because Nigeria has so many the conflict aspects and so many of the ethnicity aspects, much more than you see in other parts of the region. And so when you do the modeling, how is that squared? And in relation to that, we often on the political side, we look at this region in terms of countries in conflict and countries that are not in conflict. And those are very, very different very different baseline. And so I wonder in your research, and given that if you look at the climate issues right now, and I think Professor Ali, you mentioned farmer-herder conflicts, it's something that actually has increased across the region. And so we are likely the conflict aspect and how that impacts also the modeling that you were talking about. I have more questions, but I'll leave it for others. Thanks.
Well, I guess the plate is full. Shall we take responses then? We can take another set.
Who is starting?
Yeah.
Thank you. So first, thank you for all the questions that were highly helpful and useful. I'll just start with Professor Egbendewe and some of his responses about economic growth and infrastructure. Where is he? Oh, there he is. I think that's really important. One thing that I've seen more research on recently is the impact or the importance of small and medium-sized cities for climate adaptation. So I think if governments want to do something to improve the lot of, say, rural dwellers who may no longer be able to, say, subsist on certain types of crops, then building up the infrastructure and, say, value-added capabilities and other things of small to medium cities is an important element. Corruption, no doubt, will increase the impacts of all of these things, and I think you're basically asking about bad governance. And I think the worse things get in terms of governance and corruption, well, it's probably going to exacerbate conflict and other issues. It's simply, I think it's just a matter of time. We are interested in looking at cross-border in the context of vulnerability and adaptation, the ability of countries to adapt. And so that will be sort of a next phase, is looking more at some of these cross-border flows, looking at differential vulnerability. I think it was Nikamesa in the back who asked about whether this will create a vicious cycle or circle where new areas or receiving areas become more and more degraded. I think it is likely to do so. So it's a good observation. We see, for instance, in Eastern Africa, in our original work, a lot of migration into areas of the Lake Victoria Basin. Frankly, these are already highly densely populated regions with very little additional arable land available. So the question will be, what will people do in these areas if, in fact, they do migrate to areas that are more climatically suitable? Ngozi Amu asked the question about conflict. So yes, Nigeria is highly complex. You could, in many ways, the work could be done alone for Nigeria. I just actually traveled from there, and I realized just how big and complex it is. We were in Abuja at a meeting with government officials, and what I will say is that we, precisely because our earlier modeling work predicted a lot of new migrants in the northeastern portion of Nigeria, which we know is an area that had been affected by Boko Haram. So the original Groundswell 1 work projected migrants into those areas because of increased water availability. That is precisely why we added the conflict layer, and we wanted to try to account for that. And so that actually was attenuated somewhat when we added conflict.
Thank you very much. You have had very nice questions and suggestions. Nikes is asking how to reduce climate-induced conflict in the Sahel. I think it's a very broad question. But to me, we need two major elements. The first one is improving governance. Governance is key, a key issue in the Sahel, in all involved countries. Okay? First, the state is absent in most areas. Control of territory is an issue. You will see some spots on our map where you see no state presence, no police, no functioning judiciary, just corrupt civil servants Okay? And these are fully in conflict. This is part of the problem. So we need to improve governance. We need more international cooperation. International cooperation to bring in more funds, okay, and to contribute to addressing these security challenges. What you see in the Sahel is that the jihadists have firepower superior, widely superior to governments. They completely overperform governments in terms of military technology. And what is making the case even more surprising is that now you have almost all big powers in the Sahel. You have European countries, you have the US. Despite that, you see that jihadists are becoming increasingly sophisticated in terms of the technology they use, in terms of the engineering they use to design attacks. Attacks are becoming increasingly sophisticated. And what they do in the areas they control is that they're making sure governance is improved. They make sure the rule of law, their law, is prevalent, and they make sure the judiciary works, okay? And they are eliciting increasingly more confidence and sympathy from the population. Okay? So, to be short, we need two elements. First, improvement in governance, and two, better and more effective international cooperation and support. Now, Joachim had also made a very nice point about how to merge climate policy and development policy. I think this is a very interesting question because the two are very much intertwined, and it's very complicated to disentangle both. The problem with the climate conflict nexus modeling is that, to me, they fail to take account of this very complex situation where you have many factors playing out to bring about conflict. You have governance issues, you have conflict issues related to favoritism, you have issues related to ethnicity, you have issues related to informality. If you look at the recent figures about informality in Mali, you'll be completely puzzled by how informality is becoming overwhelming. And all this has to do with institutions. And you have all this set of issues which clearly are very hard to regress, okay, in a successful way using standard econometric techniques. Okay? You have contextual elements, you have idiosyncrasies, so you need to have regressions, of course, but you should mind about the growth rate. So this is real. But given the overwhelming burden of migration, adaptation, we have made the choice in our GRP to put the focus on adaptation. It doesn't mean that mitigation is not an issue, but it's very much dealt with elsewhere. And we just wanted to gather factual information to feed into the adaptation debate. So it's worth the choice. Thank you.
Can we just take two more comments or questions? Yes, yes, lady. Then another video.
My name is Corinne Almeida. I'm from Cape Verde Islands. Is the most common then questions I saw that in your presentation, especially you, Professor Alibai, when you showed the map about relating to the Sahel countries, and Cape Verde Islands is not included, and we are a country that belongs to this region. In some ways, some of our challenge didn't get at some levels, but for example, the unemployed is a challenge. Our population is now growing so high, it's about 2.5%, but because we are a small country, some of these challenges not so exacerbating like the other country, but yes, it's a Sahel country, so it would be, yes, to consider this, please.
Okay, the last one. Lady over there. Yeah.
Okay, my name is Beyzarit Bayena. I'm from ZEF Bonn, and I want to first start by thanking you both for a very insightful presentation. And my first question goes to Professor Ali Mbaye. You mentioned something very interesting, that you say we lack enough funding for adaptation to climate change, but you also mentioned that we have issues in governance and political institutions. So I, like as a citizen of one of the African countries that have political issues and governance issues, my question is, how much faith should we put in more funding coming and then helping us actually making any change and any impact when we see that what's coming is already not making that much of any difference? And for the second question, I come to the second presenter, Professor Shribani. And you've presented interesting points about the impact of climate change and migration, but I'm also interested to know more about the results from the crop modeling in terms of the impact that you see for achieving SDG 2, for example, achieving zero hunger by 2030, and what kind of implications do the scenarios that you look at have, and what do you think would be the possible policy options that could be used to make a difference in that angle? Thank you.
Thank you very much. Now, Corinne, is Cape Verde a Sahelian country? Yeah. Look, these issue of what country is part of the Sahel is becoming increasingly politicized. For Nigeria, for example, only part of the country, meets the physical criteria to be part of the, could be considered part of the Sahel, but not all part of Nigeria. Okay, but for Cape Verde, yeah, you're an island, as you see. A set of islands, and I haven't seen international classifications putting Cape Verde into the Sahel, but it is in. So the Sahel. So it's fine. So be it. So I don't know that. No. Yeah. So I'm happy that Cape Verde is being spared of this conflict. But yeah. Okay. We have also another question about very important issues. How to attract funding, okay, and also minding about governance. What is the guarantee that if we have additional funding, the money will not be, the resources will not be looted? So this is an important problem. But to me, improving governance means also addressing these political challenge we're facing, okay, of governments looting national resources. By some estimates, the political elites in sub-Saharan Africa are controlling up to 30% of all resources being created. And you have a lot of economic literature about how favoritism, cronyism is prevailing in Africa, and of course corruption. You're right to underscore this issue. Unless we address this governance issue, it won't help much to bring in more funding to address these adaptation issues we have discussed. It's a very good point.
So if I understood the question, it was about SDG 2 and how the migration scenarios we developed might impact SDG 2, which is on essentially food and hunger, right? I think there are quite a number of different ways that it may do that. Look at the issue of labor availability in many rural areas is already one of scarcity, so the ability to actually farm and cultivate the land. I mean, Africa still is a relatively land-abundant region, right? I mean, there's still in many areas some and there's still encroachment and expansion of agricultural frontier in much of the region. It's something that's surprising given that really agricultural expansion is saturated in most other parts of the world, except in Africa. But I think labor availability will be scarce in some of these areas of outmigration. You could, obviously the direct impact of declining water availability, declining crop yields will affect food availability. That's only part of the equation, right? It also have to deal with access and a whole range of other things. We know that in many parts of Africa, getting food to market is not, getting actual production to market is not an easy matter. So there's a whole range of intersections. I looked at that for another UN presentation at one point, and the impacts are multiple, and so it's a very good question and well taken. Thank you.
Well, let me apologize to our colleagues who raised their hands, but I couldn't recognize you. We just have to move. Very interesting session. I think the comments and interactions will continue when we go on tea break. The unemployment question, I think we have to find a way of addressing it. Most times when we talk about unemployment in this part of the world, we're looking up to government. How many people are working in the government ministries? I don't think that's the solution to our problem. Ali also mentioned the fact that the jihadis have superior firepower than government. Where does it come from? Ali, where does the support come from? Superior firepower of the jihadis. Where does it come from? Who are the backers? I think we should be interested in that. Then finally, blaming government for everything. What about the followership? When are we going to get the followership right in Africa? On that note, I want to thank all of you for this very beautiful session. Very good morning, and enjoy your tea break.
Okay, just one announcement. Coffee break is happening in the other building, in the Wascal building. And after the coffee break, we'll break out in two sessions. The first one is parallel session 5 will happen here, will take place here. While the other one will take place in the other building. Okay?
Sorry guys, to mention something. We are having 10 minutes because we are